All right, another type of word problem we're going to do in section 6.7 involve work problems. You've probably seen these problems in the past where you have somebody does a job in a certain amount of time, another person does the job in a different amount of time, and how long would it take them to do the job together? Something like that, right? Well, there's a formula that we can kind of use to help us figure out these work problems. It kind of looks like this formula here, where the first fraction is the amount of time it takes person A. The second fraction is the amount of time it takes person B to do the job by themselves, and then we can add them together to get the total amount of time it would take for them to do the job together. Now, if you think about each of these pieces, let's say it takes you 3 hours to do a job. If we think about the one whole job, and it takes us 3 hours to do this job, we can separate it into 3 little pieces. What that would mean is it would take us a third of the time to do the job in 1 hour, a third to do it in the second hour, and a third of the time to do the job in that hour. So really it's going to take us a third of a job to get done each hour. So if it takes me 3 hours by myself, then the time that it takes me to do the job is 1/3 of an hour. That's kind of where they got that formula from. Let me show you an example. Example number 5 says that Katie can embroider logos on a team's sweatshirt in 6 hours. Tracy, a new employee, needs 9 hours to complete the same job. But working together, how long will it take them to do the job? Well, let's think about the formula. Let's think about Tracy doing it by herself. Let's think about Katie doing it by herself. But if they work together, how long will it take them to do the job? Well, it says here that it takes Katie 6 hours by herself. So if it takes her 6 hours to do the job, then it really takes her 1/6 of the time. If it takes Tracy 9 hours, then it really takes her 1/9 of the time by herself to do the job. Adding them together would give us a total amount of time that they can do it together, which we don't know, right? We don't know how long it will take them to do it together. So can I say that that value is X, the amount of time it would take them to work together on the same job? All right, so now I have this rational equation. I have a couple different fractions, all of them with different denominators, but we can solve this equation and figure out the amount of time it would take them to do this job together. Let's get common denominators here. It looks like our common denominator on this problem would be, 54x? So I can multiply the first fraction by a 9x, I can multiply the second fraction by a 6x, and I can multiply the last fraction by a 54. So that way everybody has the same denominator. And we know that once we have common denominators, then we can work with our numerators and help us solve these rational equations. So my new fractions look like this. They have common denominators, so we can work with now the numerator. On my numerator, I have a 9x plus a 6x. That's a 15x, and that should be equal to 54. I can go ahead and divide by 15, and I end up getting x equals 3.6. Do you remember what x represented in our problem, though? Remember that x represented the amount of time it would take for Katie and Tracy to do the job together. Katie did it by herself in 6, Tracy did it by herself in 9, but working together, they can do the job in only 3.6 hours. So making sure that we label our answer so that we know what it means. All right, we're going to practice a few more of those work problems, but make sure you understand the concept of the two people working together to get the total amount of time.